Okay, so question 2 is pretty straightforward. And we have that define the stochastic planners problem for this economy using the recursive language, right? And they're asking us to specify the state variables and write a corresponding Bellman equation. So basically, we have that SP social planner chooses functions such as the value function, which depends on the level of capital, and the shocks, consumption, right? Gamma, investment, KZ, gamma, labor, KZ, gamma, and the optimal choice of capital, which depends on the previous stock of capital, and the shocks, right? To solve the Bellman equation, well, the value function k z gamma, it's equal to the Bellman equation of maximizing C L I K, optimal K, sorry, and taking the utility function C plus the shock times the log of leisure plus the discount factor times the conditional probability of the realizations of those shocks with the value function valued at the optimal choice of capital and the shocks, right? And this is my Bellman equation, subject to what? Subject to consumption plus investment should be equal to my production function, and that's KL. And we can actually express this in terms of what we already have, which was a Cobb-Douglas function, and we have to account for the law of motion of capital, this time taking into account the optimal decision rule, discount factor, K plus investment, right? Labor has to move or be restricted between 0 and 1. So this is how we put it. And, well, optimal paths or realizations of the shocks, which are expressed like this, right? It's rho gamma plus error terms, where errors are distributed normally sigma squared gamma, and the tech shock, which is sorry, you have to it's this one, right? So it's BZZ said, only said, plus plus error terms, and error terms are distributed normal variance squared set, right? And, well, we can actually rewrite this expression in the following manner. In the following manner. Well, we can actually take this condition, the law of motion of capital, where investment equals the optimal choice of capital minus the discount factor times the capital stock we observed, and we can plug it into here, right? And then consumption is just the production function, KL, minus investment. So we can plug this result into here, right? We have a problem here because this term is only accounted for L. So we have to express in some terms we have to actually solve for leisure, right? So great. Let's do this. So, well, taking the recursive form, where let's put it this way: taking x equal k, y equal the optimal rule of capital, and x equals, well, the convex set where the capital should live in, right? So k max, right? Then the return function is r x y z gamma equals max over L between 0 and 1 of the following Bellman equation, log, and, well, we just have to plug this in, right? So it's E z k alpha L1 minus alpha, right? Plus 1 minus delta k minus k prime, right? So we actually have k and k prime right here, and well, plus gamma log leisure, right? Which is 1 minus labor, and this should be well, living here, so such that optimal rule is in 0. And how do we get k max? Well, it's pretty forward, right? So this is actually just you can actually get it really fast from here. Remember, consumption has to be greater or equal than 0. So just these terms, E z k alpha, and we have to normalize L to the max, so it's the greatest value here. It's 1, so it's just 1 here, and plus 1 minus delta minus, k minus k prime should be greater or equal than 0, right? So this is the bound, right? The upper bound of this problem. So we're just actually gonna take this thing and paste it right here. Great. So this is the recursive form, and we finished with the second question. Thank you very much.